Section 7.6 is about graphing functions of the form ax squared plus bx plus c. And there are two objectives. For a quadratic function, find the vertex, the line of symmetry, and the maximum or minimum value, and then graph the function, and then find the intercepts of a quadratic function. So if we have an example here, f of x equals x squared minus 4x plus 7. So here we're supposed to find the vertex, the line of symmetry, and the maximum or the minimum value, and then graph the function. So what we want to do here in this example here, we want to put this in a form of x minus h squared plus k. Because then we have the vertex at h comma k, and we know how to compute the intercepts, and so that makes it really easy once we know the critical points. So with the way we rewrite the equation in this form, we write f of x equals x squared minus 4x. Now we complete the square. We divide this by 2n squared, which would be 4. But we cannot just simply add 4, so we need to subtract 4. And then we have plus 7. Now when we take the first three terms, this is x minus 2 squared, and then we combine these two terms, plus 3. So now we have the function written in this form, f of x equals x minus h squared. So this tells us that the vertex is at 3, 2, at 2, 3 rather, and the y-intercept is when x equals 0, so the y-intercept is 0, 7. And we also know it's an upward opening parabola, so we have a minimum value. And the minimum value, of course, is at the vertex. And the line of symmetry is x equals 2. So when we compute some values, x equals 0, then f of x equals 7, so the y-intercept. When x equals 2, then f of x equals 3, our vertex. And when x is equal to minus 1, our function value is 12. And when x is equal to 1, our function value is equal to 4. And so these are the points that we can use. So 2, 3 would be here, our vertex. The y-intercept is at 0, 7. That's this point here. And minus 1, 12. That's this point over here. And then at 1, 4, x equals 1, 4 would be here. And then since this is the line of symmetry, we know that the points are symmetric about the line of symmetry. So it would be here and there and up at 12 would be over here. So we can graph the parabola. So filling in the blanks, the vertex is at 2, 3. The line of symmetry is x equals 2. That's this line here, x equals 2. And the minimum value is equal to 3. and this is f of x, either in this form or in the original form. And so that's all that this was asked for. So the key to it is to rewrite the quadratic function in this form. F of x equals x minus h squared plus k, so that h and k that define the vertex, it's obvious where it is, 2, 3. For number 2, we proceed in a similar way. From the first two terms, we factor out a 3. So f of x equals 3 times x squared minus 8x. And when we are completing the square, we divide minus 8 by 2 and squared, which gives us 16. But now, since we're multiplying it by 3, we need to subtract a 48, 3 times 16, and then we have plus 43. So that means we can rewrite this as 3 times x minus 4 squared, and then combining these two terms is minus 5. So that's our function in the form ax minus h plus k. So then the vertex would be at 4, minus 5. 4, minus 5. The line of symmetry is equal to x equals 4. And the minimum value, since it's an upward opening parabola, the minimum value is minus 5. So utilizing the information about the vertex and the line of symmetry and the minimum value of minus 5, we can easily graph the function, and plus other selected values like the x-intercepts and some other points symmetric about the line of symmetry enables us to graph the function. And again, here we want to rewrite the quadratic function in the form of f of x equals a times x minus h squared plus k. So we look at the first two terms, we factor out a negative 4. So f of x equals negative 4 times an x squared minus 3x. Now we're completing the square by dividing minus 3 by 2 and squaring it. That gives us 9/4. 3/2 squared is 9/4. And now we need to add minus 4 times 9/4, or 9, to this. And then we have the minus 5. So this plus 9 cancels out the minus 4 times 9/4. This means we can now write this as minus 4 times x minus 3/2 squared plus 4. So that's our f of x. And right away we can identify the vertex as 3/2 and 4. We have 4. And since this is a downward opening parabola, since the coefficient of x squared is negative, we will have a maximum, and the maximum will be at 4, where the vertex is. So the maximum value is 4. And the line of symmetry is equal to x equals 3/2. We have some selected values for x to help us graph the function. So the x-intercepts are at 1/2, 0 and 5/2, 0. And for the y-intercept, when x equals 0, y equals -5. And then, of course, we have the vertex at 3/2, the maximum of 4. So these are the points that will help us graph the function. Plus, we know that the function values are symmetric about the line of symmetry. So we can use that fact also. So here are the points, or the points of interest from the formula. This is 3/2, 3 divided by 2. Again, the key point was to rewrite the given function in this form, to immediately write down the coordinates of the vertex and the line of symmetry, the equation for that. And then, again, since this is a downward opening function, parabola, we have a maximum, and that is equal to 4. And I also computed the x-intercepts. When a parabola is given in the form f of x equals ax squared plus bx plus c, then the vertex is given by minus b divided by 2a and 4ac minus b squared divided by 4a. Or, equivalently, minus b divided by 2a, comma, the function evaluated at minus b divided by 2a. So in other words, the x-coordinate of the vertex is minus b divided by 2a. So that's always a very easy way to find the vertex, and then the x-coordinate, that is, and then the line of symmetry is simply x equals b divided by 2a, minus b divided by 2a. And the second coordinate of the vertex can be found by evaluating the function at minus b divided by 2a. So the second objective was to find the intercepts of a quadratic function, and the point at which a graph crosses an axis is called an intercept, or called intercepts, and we determine the y-intercept by finding f of 0. In other words, we replace x with the number 0, and so it's equal to c in every case. So the y-intercept is 0, c, the constant term. And to find the x-intercept, of course, we look for the values of x for which the function equals 0. So in other words, we set the right side, ax squared plus bx plus c equal to 0, and then solve for x. And in some cases, we have the function cross the x-axis in two distinct points, sometimes in one point, and sometimes there's no intersection with the x-axis when we have complex solutions. So here we look at an example, a guided solution, where we have f of x equals x squared plus 2x minus 3, and so the y-intercept is f of 0, comma, 0, f of 0, so 0 squared plus 2 times 0 minus 3 is equal to minus 3. So the y-intercept is at 0, negative 3. And to find the x-intercepts, we solve the quadratic equation x squared plus 2x minus 3. And we can factor that into x minus 1 times x plus 3. So then we find, setting each factor equal to 0, using the zero product principle, we get x minus 1 equals 0, or x plus 3 equals 0. So x equals 1, or x equals minus 3. So the x-intercepts are then 1, 0, and minus 3, 0. So to find the intercepts for the function f of x equals x squared plus 8x plus 16, so for the y-intercept, we find 0 comma f of 0. And when we set x equal to 0 in this expression, then f of 0 is equal to 16. So the y-intercept is at 0 comma 16. And for the x-intercepts, we set x squared plus 8x plus 16 equal to 0. And we can factor that into x plus 4 squared equals 0. So in other words, x plus 4 equals 0, or x equals negative 4. And since there's only one solution, we have an upward opening parabola. And to get an idea how that looks approximately, we have the x and the y coordinate system here, x and y. Here's negative 4. And so then the parabola would look like this, and then intersects at 16. So that's the y-intercept, and the x-intercept is minus 4 comma 0. So for the y-intercept, we need to compute f of 0. And that means 0 minus 0 plus 1 equals 1. So in other words, the y-intercept is at 0 comma 1. For the x-intercept, we need to solve x squared minus 4x plus 1 equals 0. And so using the quadratic formula was a equals 1 and b equal, sorry about that, b equal to minus 4 and c equal to 1. We use the quadratic formula. X is equal to minus b, or minus negative 4, plus or minus the square root of b squared, so minus 4 squared, minus 4 times a, 1 times c times 1, divided by 2a, or 2 times 1. So this is equal then to minus negative 4 is 4, plus or minus the square root of 16 minus 4, or the square root of 12, divided by 2. Now the square root of 12 we can write as a perfect square of 4 times 3, and the square root of, so it equals 4 plus or minus, if you write 12 as a product of the perfect square of 2, that's 4 times 3, and the square root of 4 is 2, so plus or minus 2 times square root of 3 divided by 2. Now we can factor out a 2 in the numerator, and so we get 2 times 2 plus or minus the square root of 3 divided by 2. We cancel the 2's, so x has the two solutions, 2 plus the square root of 3, 2 plus the square root of 3, and the other one is x equals 2 minus the square root of 3. So then the x-intercepts are 2 minus the square root of 3, comma 0, and 2 plus the square root of 3, comma 0. So these are the x-intercepts. So this was the y-intercept, 0, 1, and 2 minus the square root of 3, 0, and 2 plus square root of 3, 0 are the x-intercepts. Let me just make sure. And this is a y-intercept. This concludes section 7.6.